Okay, let us continue. That one again. Shear force at A is going to be 8 kilonewton. It's a downward force, so it's negative again. Shear force, we're talking about forces only. So shear force at A to B, there's no force, so you are not going to calculate shear force from A to B. We are now going to shear force at B, which is this one. Shear force at B, there's an upward force acting on B. So shear force at B, for each and every shear force that you want here, you need to start where the beam starts. So we want the shear force at B, however, we're going to start here at A. So shear force at B is going to be -8 and then plus 17 kilonewton. It's plus because the RL is acting upwards, okay? So an upward force we add. So we got +9 again. And then shear force from B to C, we need to start here where the beam starts. So it's going to be -8 plus 70, and then we have a UDL that is acting from B to D again. However, we want the shear force from B to C, not from B to D. So this UDL is 2. What is the distance? Is it 4 or is it 2? It is 2 because here is an example. We have a UDL. This UDL is acting from B to C. It's acting from B to C. However, we want the shear force from B to C. We want this part. So which distance is from B to C? It is 2, not 4. This 4 is for the whole entire UDL. We want the distance from B to C. Hence, we are choosing 2. Like, so it's -8 plus 17, which is the upward force, and then -2, which is the UDL, multiplied by 2. The reason we're multiplying by the distance is because it is a UDL. So UDL, you need to multiply by the force. So it's -2 times 2. What do we get? +5. +5. So now we're going to shear force at what? Shear force at C. This one again. So shear force at C, how are we going to calculate it? -8 plus 17 minus -10 -10 -2 times 2. What do we get? So here it's shear force at C again. This is shear force at C. We start from the beginning. It's like -8 plus 17. From B to C, what do we have? We have a UDL, which is 2, and then the distance is 2 again. So -2 times 2, and then we have a force that is acting on C, which is 10, and it is a downward force, so it's negative. What do we get? -5. So now we're going to shear force at what? C to D. At C to D, there's a force. Here, the reason we did not do from A to B, there's no force, there's no UDL, there's nothing like one again. But from C to D, there's a force. That's why we're calculating the shear force from C to D. So how are we going to calculate the shear force from C to D? -8, we start here, and then plus this RL, which is 17, and then -10, which is the force that is acting on C, yes? -2 times? -2 times 4. -2 times 4. Yes. What do we get? If I let what do we get? Negative -9. Come calculate -9. No, I don't agree with your shear force, but let's just try everyone. -9, and then shear force at D. Shear force at D. -8 plus 17 -10 -2 times 4 plus 17. What do we get? 8. It's shear force at what? Shear force at D. Okay, and then shear force at what? Shear force at E. There's no shear force from D to E again. So shear force at E is going to be Multiply by positive 8 again. So it's going to be 8 and then minus 8. I want to recreate is equal to 0. So okay, another way to do it, sorry, more even. Shear force from C to D, you can say negative 8 plus 17 minus 10 minus 2 times 2 minus 2 times 2. Mara sharpening, so minus 2 times 4 and then minus 8. Is sharpening the way. So shear force, the last shear force needs to be 0 again. So we got it.